So I built out an agent to make OpenEMR, which is an open source software for healthcare professionals, be more quick, more intelligent, and help physicians out. And this is a great thing you can do if you want to build agents with open source software because you can help out a lot of people. So this specifically is helping out doctors, and there's a lot we're going to go over today. For this build, I'm going to get into the agent framework and orchestration, into the RAG pipeline. I'm going to be getting into the testing, evaluation, and the CI gate. We're going to be doing a lot of really cool stuff with this build, and it's only going to get better and better as more videos are made and I'm putting out more and more stuff. So let's get into the build. So the agent framework and orchestration is being done with LangGraph, which is a multi-agent supervisor worker graph. We're using Fast API, which is the agent's HTTP API being used. We have Uvicorn, which is the ASGI server. And we're also using Pydantic, specifically version 2, which is for strict frozen schemas, the citation contract, and config information. Now going deeper into the RAG, the RAG pipeline is being used with hybrid retrieval. This is being done fully local. There's no external vector database. And this is specifically being done for HIPAA. There's a lot of things attached to health data and PHI. So we're making some intelligent decisions with that in mind and around that. So we're using rank BM25, which is the BM25 retrieval. We have FAISS, which people know as metas. We're using that for the dense vector index. Now the reciprocal rank fusion is merging the two. We are using sentence transformers for our embeddings and re-ranking. Then the BGE small is used for dense embedding as a model. And then the MS macro mini LM is a cross-encoder re-ranker. So we are using PyTorch, but it's just being used CPU only. It's the runtime underneath the sentence transformers. So I just wanted to make a note of that. Now, as far as the document processing, we're using multi-model source grounding. We are using PDF Plumber for the PDF text and word bounding boxes, which is a visual overlay that you will see in the demo. We're using PyPDF, which is PDF page handling, and we're also using Report Lab, which is a synthetic text layer demo for the PDFs. Now, I want to get really into the EHR integration and auth. EHR stands for Electronic Health Records. You're going to be dealing with things like I mentioned previously with HIPAA and just really specific standards for how you have to handle data because it needs to be locked down. With HIPAA, if you have something touching something that's currently HIPAA compliant and it's not HIPAA compliant, then everything loses its HIPAA compliance. So this is very important. And this is why I'm going to get into this very specifically and why we're doing things this very specific way. So auth runs through OpenEMR Smart on FHIR and OAuth 2. So the agent acts as a logged in doctor, giving per user identity, scoped access, and full auditability, which is exactly what HIPAA's access control audit and minimum necessary rules require. And you can see right here what we're using. OpenEMR is the electronic health record system. Obviously, it's what we forked, what we're building this agent for. Smart on FHIR is the EHR launch. It's a silent launch bound to the logged in doctor. FHIR R4 is the document reference. OAuth 2 is obviously the token flows. And then we're using HTTPX as the async HTTP client to OpenEMR. Now, for the observability and resilience, we are using structlog, which is structured JSON logging and correlation IDs, Langfuse for LLM tracing, and Tenacity, which retries with back-off circuit breaker helpers. Now, moving along, for testing evals in the CI gate, we are currently using PyTest. We're using a whole suite associated with it: PyTest Asyncio, PyTest HTTPX, RESTPX, PyTest COV. Basically, it's a whole test suite, and we're going to town with PyTest. We also set up a golden eval gate. We put into this project 50 case Boolean Rubik regression gates. So there's a ton of different evaluations we just popped out with for the golden set. We have a PHI scanner. We have a Git pre-push hook set up as well. For that hook, we're basically have it to be a hard gate. So it goes from lint to coverage to eval regression to PHI. We're also using Locust for load testing and OpenAPI, specifically 3.1 in this project, which is committed as a contract snapshot and a drift guard as well. So for data generation, I'm using Cynthia, which is just for patients for dummy data, basically. Obviously, others technologies associated with this that are in the product is going to be just vanilla HTML, CSS, JavaScript. I'm going to be pushing it up live on Railway, and I'm using local containerized agents just to build out with Docker. So I'm going to start now with, this is my repo. It's under secret Git account. It's under OpenEMR. And this is the fork of OpenEMR. And you can see if you go to agent, this is everything I built out for the clinical copilot agent. Now I am putting it through Railway, and you can see right here, it's using MariaDB and OpenEMR. This is the fork I did. And then everything's online. I have the agent online as well. So let me do a quick demo. So right now I will go in and sign in to OpenEMR. And I'm going to pull up a patient. So let's just pretend right now I'm a doctor. I'm going in. This is dummy data I put in. So you're looking right now at basically what the doctor currently has access to. And the problem is the doctor has to make decisions. And he's going around from one patient to the next. So what did I do? I just created a clinical copilot. So right now what it's doing is all of this was loaded. The chart summary, AI, the caveats, all loaded through AI. And this is taking all the information you saw previously and just summarizing it. This chart loaded right here, it actually checks for, I have it auto caching, view something, so it doesn't have to run up a bunch of API credits. What the agent's doing, these are PDFs that it's actually reading. And over here is a preview where if you click on a lab observation, it literally pulls up the PDF. It shows you where in the PDF it is pulling it from as well. Not just that, but there's also now a whole chat with, does this patient have diabetes? I will go into Langfuse right after this and show basically the tracing and just everything that's happening when it comes to how much it costs. You can see right here, the doctor can chat directly with AI within this whole chat bot. And there's actual references too within the chat. You know, it's giving its references directly to the doctor. If you close out of this agent, you can see this is what they're usually just looking at. They don't really have that big of an idea around the patient. They have to kind of look all over the place. And so AI can really just help enable this doctor get everything done really quickly. Show the, right here I have the scores. And you'll see the evaluators are empty, and that's because I'm doing a mental model, which is PyTest, and it pushes these directly into Langfuse to look at the scores. And that's evaluation specific. Use Langfuse as a place to house it. The observability is being done with Langfuse. So here you go. You can see the outcome, how many tokens. Also, you know, this was 2 cents. So just really tracing the costs and everything across the board really helps out a lot. I love Langfuse. You can see right here, when I'm looking at getting records, it's pretty cheap. So the build methodology on this project was PRP driven, eval-gated agentic development, basically. And I'm looking forward to getting into the next videos when it comes to just all these really cool things, basically building from zero to showing the product. So far, I've been basically going to technologies used, why I use them, what the stacks were, and everything that goes into building, and then doing a demo of the finished product. Now I'm going to be going deeper into specific aspects of what I'm doing step by step to build. Thank you for watching, and there's going to be a lot more videos coming out.